Myself, Ramu. I'm currently pursuing MTech in Computer Science Department, and today I'm going to discuss project named the Bitcoin project price prediction. And moving on to the implementation part, I have imported some necessary uh, required tools such as NumPy and Pandas. And NumPy is used for linear algebra, and Pandas is used for some data processing and CV and also IO files. And this is the data set I have downloaded from Kaggle, and this is where I loaded the data set. And I have loaded the dataset file, and I have downloaded the dataset from Kaggle, and this is the display of the dataset that I have taken from the Kaggle, and we are having some timestamp and open of the Bitcoin price and open of the Bitcoin, and we are having high values, low values, and the close time, and the volume of the Bitcoin when the time closes. And this is and one under column we have date and time where the Bitcoin time closes. And this is the shape of data. These are the rows and these are the columns, and these are the types, some of the types in the data set that we are going to use for this Bitcoin prediction. And this is some, and this is the summary statistics of the data set, and we are having open values, high values, and low values, and also close values. That open in the sense the Bitcoin price open value, and this is some where the high in the sense the Bitcoin value increases, and low in the sense the Bitcoin minimum value, and this is the time where the Bitcoin closes. And we are also getting some we also calculated some mean standard deviation and minimum of that Bitcoin and maximum of the Bitcoin. And this code is evaluated for null values and to check the null values in the data set. And I have changed the function df to data. And we are converting this was the in the data set we are having Unix time, so we are converting that Unix time into date time for our readability. And we are also resampling the daily frequency into numeric columns that will be averaged, and also we are also resampling monthly frequency using this code, and we also resampling the annual frequency of the data set, and also we are also resampling the quarterly frequency of the data set. And we are handling some missing values in the every column, like we found some missing values in df daily column, and with this we are handling with fill now, and we are filling some mean nearest value to that null values to get good results. And this is how we calculate the percentage change in the Bitcoin price, and we also calculated 3-month moving average, 6-month moving average, and also 12-month moving average. And we also calculated a 3-month rolling standard deviation of DF quarterly, and also 6-month rolling standard deviation of DF quarterly. And this is how after filling the null values, this is how the data sets look like. And this is the code for converting Unix to date time. And this is how the graph looks like. The trend shows how it evolving from time to time, the Bitcoin price, and this shows the closing price, and this shows over time. And this is the candlestick chart that shows us financial chart that shows open, high, low, and close of the particular data set. This is how the graph looks like. The Bitcoin candlestick graph chart looks like. And we also plotted the histogram of Bitcoin daily trading volume. This is how the Bitcoin daily trading volume for that particular data set looks like. and this is the scatter plot for Bitcoin closing prices, and it is taken with the volume. This is how the uh, graph looks like. On y-axis we have taken volume, and on x-axis we have taken closing price of the Bitcoin. And this is the box plot of the Bitcoin daily trading volume by every month, and this is how the outliers and the graph looks like. And until now we have just checked the trends and the workflow, the flow of the Bitcoin. Now we are going with some model selection. We have gone through some models like ARIMA, Sarimax, and also gradient boosting, regressor, and lastly we have taken LSTM for the comparison to find the Bitcoin prediction, Bitcoin coin prediction. And we have imported these from using these modules, and have trained like 80 into 80 plus 20. And this is the min-max scaler used for scaling the data. And ARIMA, I trained ARIMA model which uses past values of closing price to predict the future one, but it takes only short data. And whereas ARIMA, it takes seasonal data. If the trend is increased, if you consider like this is the month of April. In last April, if the Bitcoin price is increased, Sarima predicts like in the next coming year also in April the Bitcoin price will be increased. This is how Sarima works. And I also trained LSTM model, and unlike Sarima and Arima, it can also learn non-linear patterns and remember long-term dependencies. Not like Sarima, like seasonal predictions, or not like Arima. LSTM sees the long-term dependencies. This is the code for LSTM model. And also gradient boosting, which is nothing but it learns from mistakes. It builds multiple decision trees and checks if some tree predicts wrong, then it will say you are predicted wrong, then it goes to another tree. This is how gradient boosting works. It learns from mistakes. And this is the gradient boosting, therefore the gradient boosting regressive model code. And also this is RMSE, which is nothing but root mean square error, which is used to find the values for our models, Arima, and LSTM and gradient boosting models. And least the root mean square better the performance. And it tells the performance how far with actual predicted price. And this is the plot of comparison of root mean square comparison of predicted models. This was the results we achieved, and I can conclude that long short-term memory works well in predicting the Bitcoin compared to Arima, Sarima, and also gradient boosting regressor. Sarima also in sometimes will get good prediction, but we cannot depend whether it will be work out or not. Arima takes less dependency, so we cannot also depend on Arima. And gradient boosting regressor, it learns from its mistake and by building multiple decision trees. But compared to LSTM, which is RNN model and which is used for vanishing, which is used to overcome the vanishing gradient problem. So I can conclude that LSTM is the better model in our experimentation in the implementation of Bitcoin predictions.